Hi, this is Jianhong Zhang, and I'm going to do homework 5 for probability and the stochastic process. And in this week, we have learned the convolution method to figure out the PDF function. And in this question, we have got the x and y are independent, and x and y are both step functions. X is from 0 to 1, and y is from 1 to 2. And we have got z is equal to x plus y, and we need to find the PDF of z. Okay, with this convolution method, and we have seen that these two conditions, this one and this one, are both conditions that allow us to use the convolution method. And in convolution method, we're going to use that the PDF of z equals to the fxx convolution with fyy. Okay, in this convolution, we can use the function of x to shifting from the negative infinity to positive infinity, and multiply with y when x is equal to whenever x is shifting x times with y. And with this times, we can easily to draw in like this. This is x, this is y, and this is the convolution. So when the right side of x just move to the left side of y, then just from 1 to 2 of z, and this time the convolution equals to 1. So the slope is 1, and after the x is going to leave at y, so the line is gonna to decrease. So the convolution result is drawing like this. We have learned that this method in the signal and system courses, and so we're gonna use this picture to write the PDF of z like this. Okay, and I'm going to figure out what we do with the definition and using the geometric method. And okay, we have seen that this is y, this is x, and we have known that distribution function of z is equals to the integration from d for fxy dx dy. And we draw d in the shadow like this, which x is from 0 to 1 and y is from 1 to 2, and this shadow is the d. However, and now we must figure out where is z happened. Okay, and we must figure out there are 4 conditions that if z is less than 1, so z is here, and this line is z, is y is equal to z minus x, that is x plus y equals to z. When z is lower than 1, so this shadow is effective, but there is nothing. So when z is less than 1, the distribution function is 0. And when z is in the 1 and 2, is here, and this little triangle is the effective shadow. So we can write the distribution function is the triangle. We already know that fxx and fyy is always equals to 1. So, and after integration, we found that the distribution function of z is just equal to the area of the little triangle, which is z minus 1 square over 2. And similarly, when z is in 2 and 3, that line draw like this and just intersect with this kind of shadow, and so this kind of triangle is effective, and the area is using the whole area of the square minus this kind of area. Minus this kind of area. So I can write it like this. It's 1 minus 3 minus z squared over 2. And very similar, and the most easy condition happens when z is more than 3, like this. So all the shadow are in the effective. So that is the area of the shadow is just 1. So what about the PDF of z? We know that PDF of z is the differentiate of the distribution function. So when z is minus than 1, when z is less than 1, so we have PDF of z is 0, and in 1 and 2, and we differentiate this kind of equation, we can draw in like z minus 1, and in 2 and 3, and we differentiate this kind of equation, we can write it like 3 minus z, and after z is more than 3 and the distribution function is 1, so the differentiate function is 0. Okay, so we're gonna see that using the geometric method and the convolution method, they are the same, right? Okay, and this is the whole question about this is a whole solution about question 1 and made by Jianfeng Zhang. Thank you.